Bismillahirrahmanirrahim. Welcome to the course code Eng455 Linguistics Part 1. I'm your instructor Dr. Ansar Hamid, teaching you linguistics. Today our lecture number 5 is actually the extension of our previous lecture on phonetics. If you remember, last week we started with phonetics, a branch of linguistics which deals with the study of speech, human speech sounds. So today our focus would be some more branches of phonetics. Last week we discussed what phonetics is, what are the three main sub-branches of phonetics like articulatory phonetics, auditory phonetics and acoustic phonetics. As I explained in my previous lecture, that human speech sounds is a three-dimensional process. We utter sound waves, these sound waves travel through a medium, and then finally these sound waves reach to the ear of the listener. So three steps are there: the production of speech sound, the traveling of speech sound, and finally the perception of speech sound. The branch of phonetics which deals with the production is known as articulatory phonetics. The branch which deals with the transmission of sound waves is known as acoustic phonetics. Whereas auditory phonetics is all about the perception of speech sounds. Last week we only touched the last two branches, that is acoustic and auditory phonetics. I gave you a brief introduction, but our major focus area was articulatory phonetics. In articulatory phonetics we discussed the three dimensions, that is voicing, place of articulation and the manner of articulation. If you remember, we also studied the speech organs which are involved while production of speech sounds, and then what are the special organs in our mouth, in our including the vocal cords and the trachea, which help us to produce certain different types of speech sounds. But at the same time, how when these places of articulation changes, then the manner of articulation as well changes. So all of these things related to articulatory phonetics we discussed in detail in our previous lecture. So what is our focus of study today? Yes, today we are going to focus on acoustic phonetics and auditory phonetics. Acoustic phonetics related to the transmission of sound waves. So we are going to study what the sound waves are actually composed of. What are the things which are very important while studying these sound waves, as well as we will discuss and study an important tool that is used to record these sound waves and is very useful nowadays. With reference to auditory phonetics, we will study the different organs which are involved in reception of sound, including the ear and the brain, that how there are different parts of ear which help to collect the sound waves, and then they correspond these sound waves from outer ear to the nerves, and then nerves to brain, and finally we get something into our brain, we receive the message, we listen to the sound and we get the understanding of those speech sounds. So today our focus is on acoustic and auditory phonetics. We will start with acoustic phonetics. First of all, what is the exact pronunciation of this word, acoustic phonetics? So in acoustic phonetics, we are going to study that how the sounds are perceived. It is branch of phonetics that deals with the frequency and amplitude in the transmission of speech sound. So the sound, when we will study the structure of sound waves, we will come to know that what is meant by frequency and what is meant by amplitude as well. Another thing, an acoustic phonetician studies the waves of the sound. that the waves, when a speaker produces certain sound waves, they are transmitted and then finally received by the ear. How these sound waves, they enter into our ear, and how we can study and analyze these sound waves with the help of a special instrument, as I mentioned, spectrograph. So a acoustic phonetician is concerned with all these things. Another definition of acoustic phonetics is, acoustic phonetics investigates properties like the mean, square and amplitude of a waveform, because the sound waves, they travel in the form of sine waves. What are these sine waves? We will discuss. So actually when these sounds, they travel in the form of waves, in acoustic phonetics we are concerned with the wavelength of the sound waves as well as the time duration it takes plus the frequency, because the fundamental frequency of the waves, sound waves, helps us to study the different features of the sounds. This way we have the sound frequency spectrum to calculate the frequency of the sound waves and also to calculate the wavelength of the sound waves. So these all phenomena are the major concern areas for acoustic phonetics, because it is an important dimension from production to reception of speech sound. If speech sounds are produced, they are transmitted. But if we are not aware of the phenomena that how these sounds are actually received by human beings, then our study of these sound waves would be incomplete. So this acoustic phonetics is quite important to study how the sound waves, they travel from one source to another source. If you look at the figure, the sound waves production, yes, and then these sound waves, they travel in the air in certain form, and finally they reach to the hearing organ, that is ear. So this way the sound waves travel from one medium of production to the other medium of reception, and in between this process the sound waves, they travel in certain form. Acoustic phonetics is concerned with the in-between process, that when a sound is produced by a medium and finally the same sound is received by a medium, in between how these sound waves, they travel through air, and what are the different phenomena and what are the different things which are related to these sound waves. So aspects of sound transmission. Every sound, whether speech or non-speech, here I am talking about the waves. Now these sound waves, whether they are related to speech, like speech the way I am talking, but at the same time there are certain non-speech sound, for example producing a, u, e. These kind of sounds, though they do not have any correspondence with the actual speech system, but at the same time these are the sounds which are non-speech, but still they have certain meanings with reference to their production. So the sound waves, whether speech or non-speech, begins with a body of air. I'm not talking about the person who is producing sound wave, or I'm not talking about the medium who is receiving these sound waves. I'm talking about the medium through which these sound waves are actually traveling. So when these sound waves, they travel in a certain medium, actually what happens, they set a vibration. A set of vibrations is set by these sound waves in the air. And it is this vibrating body of air which actually stimulates the nerves of the auditory system. If the waves are not here, nothing is going to stimulate the auditory system. What is the thing that is going to stimulate the auditory system are actually the vibrations. When we utter certain speech sounds, they are going to disturb the air particles, thus causing vibration in air. and then these vibrations, they reach to the auditory organ. As a general rule, a forceful initiation will result in a relatively loud sound. What happens if we are going to blow a powerful puff of air causing a powerful sound wave, then as a result the auditory organ will receive a loud sound. And if we only have a low pressure sound like whispering, hello, so these kind of sounds, they are heard or received by the listener as low sounds. So this way it all depends on the vibration of the air particles that through which the sound waves actually travel. So before starting that how these sounds they are actually transmitted, it's very important to know what are actually the sound waves. If you look at the picture, the sound waves, when we utter certain sounds, there are certain layers that moves in the air. An interesting example of these sounds is just like the pendulum. If you set a pendulum in air and let it free, then it will start vibrating to and fro around a mean position. And when it moves from one point to another, actually what it causes, it also causes certain vibrations in ear. So in the same way, when we utter certain speech sound, it's going to set certain vibrations in the ear. So we will start from what are the sound waves, because these are the major components of the study related to acoustic phonetics. Sound is caused by a vibrating object. This is the very first condition for producing a sound. A body, if not set on the vibrations, is always unable to produce sound, because when the body will vibrate, then it is going to disturb the air layers. And if the body is not vibrating, it means it's not going to disturb any air layer. So as a result, no sound wave is going to travel, and finally no sound wave is going to reach the auditory organ. So the first condition to produce sound waves is that the body that is producing certain sounds must be vibrating. So a vibrating object can produce a sound. The interesting example is tuning fork. If you remember that if you have ever experimented in your matric classes, if you have science subject, you would be very much familiar with what tuning fork is. Actually, it is a fork-like instrument with two pointed top areas, and when we move one prong of that, we shake or we force to vibrate the one prong of that tuning fork, it starts moving, vibrating like this and this way, just like the pendulum. So it is a vibrating body, and when it is a vibrating body, it means it is going to set a sound wave. Now what is the procedure? When the arm of the tuning fork moves outwards, it crowds the neighboring air molecules together, raising the air pressure in the area. The crowded air molecules will tend to move into less crowded lower pressure areas, which causes those areas to get crowded. And this procedure continues, and thus setting a set of crowded areas, the high pressure areas, after every certain period of time. So this way, when the prong of a tuning fork, it moves outwards. When it moves outwards, because it causes the pressure on the next layer of the air. So this way the next layer it gets pressure and transfers to the next layer. The next layer gets pressure and transfers to the next layer. So this way a set of high pressure it starts moving towards the other source, towards the other side. Now, because the prong of the tuning fork is made in such a way that it not only moves outwards but also at the same time it moves inwards as well. So what happens when it moves inwards? It reduces the air pressure, so making a layer of air where there is low pressure. So as a result, this layer of air, it transfers this low pressure to its next layer. The next layer transfers that low pressure to the very next layer, and the next layer to the next layer. So this way the low pressure areas, they start shifting from one layer to another and to another and to another. So this way a set of low pressure air layers is set. So at this happens to that when a tuning fork moves outwards and inwards, setting the high pressure and the low pressure or the vacuum areas. If the pressure is too low, sometimes it also creates some sort of vacuum as well. So this way we get two sets, one set of high pressure, the second set of low pressure. So as a result, these two sets, because they are happening at the same time, so we have two sets moving at the same time, two sets of layers of airs moving towards a certain direction. This combination of two high and low pressure areas, two packed and unpacked air pressure areas, they form a sound waves. And what has created this sound waves? A vibrating object. And this combination of high and low pressure area makes a sound wave. If you look at this picture, this is what is called a tuning fork, and these are the prongs of the tuning fork. Now what happens when you vibrate this tuning fork, or when you set in movement one prong of this tuning fork, it will start moving like this way. So this way not only it moves in the forward direction, but at the same time it moves in the backward direction. So when this prong it moves in the outward direction, what happens that this prong it causes the high pressure on the air layer. If you see here, these are the high pressure areas. So as a result, the air layer it transfers this air pressure, high air pressure, to its next layer. If you look over here, this is again a high pressure air. Now again what happens, this air of layer it transfers this high pressure to its next layer. So once again this is a high pressure area. So these are the high pressure area. This is the way that when a prong of a tuning fork moves outwards, it disturbs the next layer, causing the areas of high pressure. But on the other hand, when this prong moves backward, what happens that it creates the low pressure area or a kind of vacuum. If you just look at the second part, this area of the picture, this is the area where there is low pressure. Because the prong is moving inward, so the pressure on the air is reduced. As a result, the low pressure area is caused, or sometimes if the pressure is too low, the vacuum area is created. So this air of layer, when it creates a low pressure air, then it transfers this air pressure to the next layer. Now this is the second area where the low pressure is caused. Same thing happens, repeats again. This air of layer transfers the low pressure to this area. So this way a set of patterns is created where the air pressure is low. Now if you look at the whole thing, then there is a design, a set pattern of high pressure area, low pressure area, high pressure area, low pressure area, high pressure area, low pressure area. A chain of two sets of vibrations is, two sets of air pressures is created, high, low, and this is what creates a sound wave. This is actually a sound waves. In some terminological or physics terminology, these are known as compressed and rarefied areas, but with relation to acoustic phonetics or with relation to sound waves, we call them the high pressure areas and the low pressure areas. I hope now what a sound wave is very much clear to you, that how a sound wave is created. A sound wave is actually something that creates a set of high pressures and low pressures in air and then creating a sound wave. But when we are going to graphically represent these sound waves, it's very hard or very complicated to draw it in the waveform of these compressed and rarefied waves. So what we do, we represent these sound waves in the form of sine wave. So this is a convenient way to diagram a sound wave, that we graph what happens in this graph, that all the high pressure areas, they are the upper portions of the sine waves, and all the low pressure areas, they are the below portions of these sine waves. Now what is a sine wave? This is a sine wave. If you look at the picture, this is a sine wave, up, down, up, down, up, down, and all the upper portion, the upper portion, they are the high pressure areas, whereas all the lower portion areas, they are the low pressure area. So this way we can present the sound waves in the form of diagram. Now the midline is drawn. If you see, there is a midline, black midline. This midline represents the neutral areas. Above this midline, there are high pressure areas. Below this midline, there are low pressure areas. So this way we can represent a sound wave in form of a sine wave with high and low high and low pressure areas. Now, what are the important terminologies which are very much important in relation to the sound waves? The first thing is amplitude. In relation to the graphs, this thing is known as amplitude, but in relation to sound, this amplitude actually depicts the loudness of the sound. What is an amplitude? The amplitude of a wave is the size of the pressure difference it causes. Actually what happens, as I explained it to you, that the air sound or the sound wave, it is a combination of high and low pressure. So what happens, that these areas of low and high pressure, their size together creates an amplitude. Amplitude of sound waves is usually measured in decibel, shown as dB, and people hear amplitude as decibel. If you look at the picture, as I told you, this is a sine wave, up, down, up, down. In between there is a zero, a neutral line. Now from that mid-zero neutral line to the top point of the high pressure area, or even from midline to the low pressure area, the peak of this distance is known as the amplitude. So this is amplitude, and the size of the amplitude determines the loudness of your sound. Now what is the next important thing is wavelength. The wavelength of a wave is the physical distance between two comparable points in neighboring cycles. Now if you look at the figure, this is a sound wave. If we call it a sound wave, then what happens that over here in this figure, the top point of the high pressure area up till starting from that to the next top point of the next high pressure area, the distance in between is known as the wavelength. If you look at this figure of the sound waves, now this is the area of high pressure for one sound wave, this is the area of high pressure for the second wave. Now the distance from this point to this point, this is the wavelength. If you define it with help of low pressure area, then if you look over here, this is the one lowest pressure area and this is the another point for low pressure area. So again the distance from here to here, this is known as wavelength. For phoneticians, the people who are interested in phonetics, though the frequency and the amplitude is very much important, but wavelength is of very little importance, because wavelength does not define any quality or anything property related to sound. Now next, another important thing, frequency. What is a frequency? For a sound wave, frequency defines the pitch of the sound. But if we define frequency with reference to physics or with reference to waves, then the frequency of a sound waves is how often the wave repeats itself. That how much time, for how often time this is going to happen, that a sound wave is going to repeat itself. This is known as frequency. Frequency of a sound wave is measured in Hertz, abbreviated as Hc. Sometimes the people, they call it cycles per second. It is actually a definition of a frequency, that when we define in a strictly scientific term, then a frequency is a cycles per second. How much cycles of sound waves they are created in 1 second. It is known as the frequency. Now when people, they hear the frequency, they hear it as the pitch. As you know that the people, they have the different type of voices. We have the people who have low pitch voices, the people with high pitch voices. The most often example that is given is of males and females. It is said that males, they have a very loud as well as a very high pitch voice, low pitch voice, whereas the females, they have a high pitch voice and they have a shrill sorts of voices. So this way the frequency of the sound waves, it actually defines the pitch. That what is a pitch? It is a pitch is actually the frequency, which is the cycles per second. So if the people related to acoustic phonetics, they want to measure the pitch and the loudness of human voices, they will use certain instruments to calculate, to trace these sound waves, and from these sound waves they will calculate the frequency and amplitude, and with the help of that amplitude and frequency, they can tell the pitch and loudness of the sound. So far we have studied what a sound wave is, what are the things which are important to know about a sound wave, especially the pitch and the pitch or frequency, or the wavelength or amplitude. These things are the important terminologies related to sound wave. For most particular purposes in acoustic phonetics, we don't care about the actual complex waveform itself. We are only interested in the frequencies and amplitudes. of the simple waves that it is made of. As I told you that the two most important things that are related to sound waves are the pitch and the loudness. So to measure the pitch and the loudness, what we need to trace from the sound waves is the frequency and the wavelength. So to measure these two things, what we trace the sound waves, and then on the basis of this data we can differentiate between the voice quality of different people. Now I am going to tell you about a very important and useful instrument that is used in acoustic phonetics: spectrogram. What is a spectrogram? Spectrogram is actually used to identify spoken words phonetically and to analyze the various calls of animals. You know, it is a very useful device to trace the sound waves, and on the basis of the data it can tell about the voice quality, it can differentiate between the voices of the different people, so many things are related to actually it. If you are very fond of English movies, you have heard about an instrument that the people of CID and CIA, they use a special type of instrument and they attach it with the people, and by using that instrument they can tell whether the person is telling a true statement or a false statement. So actually they use some such sort of spectrogram. These devices are very much in use, and these devices are very much practical as well, to know about the quality, to know about the distinction between the people or having the different voices. At the same time as this device of acoustic phonetics is very much popular in the field of music, sonar, radar and speech processing and seismology. These are all the different branches of knowledge which make use of a device that is spectrogram, and is particularly based on the knowledge of acoustic phonetics. The instrument, this generates a spectrogram. Now what happens, that spectrogram, it generates certain types of graph. They actually represent the sound waves in forms of certain graphs, and these graphs, they are known as spectrographs. This figure is actually showing an image of spectrograph, that how a spectrograph represents the sound waves. A spectrograph, when it traces, analyze the sound waves, it represents it in the forms of these darker and the light area. If you look at this part, this is the dark area, then the light area, again the dark area and the light area. So a spectrograph, it represents the sound waves in the form of these dark and light areas, and these dark and light areas together, they represent the sound waves. And now again, how we are going to measure the pitch and the loudness? Again, if you look over here, if we call it the middle point, then from this middle point to the top point, this area will give you the loudness of the sound. Similarly, by measuring the cycles per second, then in 1 second how much cycles are created, we can calculate the pitch. And by combining these two aspects, we can judge, we can analyze the voice quality or voice, we can make distinction between different kind of speech sound. So this is an image of spectrograph. Now if we move towards the next slide, in spectrogram the horizontal dimension represents time to calculate the pitch, and the vertical dimension represents the frequency. each thin vertical slice of the spectrogram shows the spectrum during a short period of time, using darkness to stand for amplitude. As I told you that on a spectrograph there are dark and light areas. Wherever there are darker areas, they are representing the amplitude. And on the other hand, there are certain areas which are less dark, from where we can calculate the frequencies. Frequency of the darker areas shows those frequencies where the simple component waves have high amplitude. So this way, with the help of amplitude and frequency, we can trace the sound wave. So far we have studied in acoustic phonetics that how acoustic phonetics, it deals with the phenomenon of sound, what are the things which are very important in relation to sound waves, and what is a spectrogram, and how with the help of a spectrograph we can judge the voice quality, we can calculate the pitch and the loudness of speech sounds. So this way we can get a trace of the human speech sounds, and even sometimes we can make a trace the animal speech, animal sound, speech sound, though they are not some sort of language, but still we can utter, we can analyze what sorts of sounds they create. On the whole, now our last point is what are the applications of the acoustic phonetics? Number one, acoustic phonetics deals with the physical aspects of speech sounds associated with the production and perception of speech. So acoustic measuring techniques can be used by speech language pathologists to assess and treat a variety of speech disorders. Because these pathologists and the people who are concerned with the language analysis, they can use this knowledge, they can use these devices to treat certain kind of disorders, language disorders. Secondly, when ear-based approaches are inadequate, when our transcriptions are inadequate, then acoustic analysis offers a useful tool in this process to prove that our descriptions and transcriptions are correct, because they very accurately trace the sound waves produced. Then they can give you a very accurate information and description about the quality, about the nature of the speech sounds. Third place, acoustic analysis provides a clearer difference between two speakers, pitch value, than the auditory analysis. Because in auditory analysis, by hearing, you can give an oral judgment that what kind of pitch or sound loudness a person's sound has. That by hearing to a sound you can tell, yes, whether she or he has a low pitch sound or a high pitch sound. But on the other hand, these are your oral judgments. But on the other hand, with the help of acoustic analysis, you can accurately tell the pitch and the loudness factors of the sounds. Number 4, males usually speak at a lower pitch level. As I mentioned earlier, that males, it is said that they have the lower pitch voices and less shrill voices than the females. So how we can generalize this? If this is only an idea, to prove this idea, again we can use the tools and the procedures from acoustic phonetics, and we can prove, yes, whether or not the males, they have the low pitch voices or not. So this way you can get a proof for a certain type of knowledge. And lastly, loudness, pitch and nasal resonance are aspects of acoustic makeup of the speech signal, and we routinely use them to identify speakers and to decode mood. For example, you have a phone call, and when you attend the phone call, right from listening to that voice, you can tell that who is speaking. A young person or old person, a child, a person you know or a person you don't know. You can, with that voice, so many things are associated. And what are those things? Definitely, these things are the pitch and the loudness and these nasal resonant factors that characterize and that attribute a human speech sound of a particular person. So this way, with the help of acoustic analysis, you can analyze, you can differentiate between the people having different types of voices and the voice qualities. So this way, the acoustic analysis is a very important and a useful branch of phonetics plus linguistics to provide you certain sort of knowledge related to human speech sound. So far, we have discussed things related to acoustic phonetics. Now, next we are going to move towards the auditory phonetics. As in my previous lecture, I gave you a brief introduction about auditory phonetics. That what is auditory phonetics? It is the study of how sound waves are perceived by the listeners. As I mentioned in the beginning, that sound waves, they are produced, they are transmitted, and finally they are received. The first area is of articulatory phonetics, the second area is of acoustic phonetics, and this last area related to perception of sounds is the area of auditory phonetics, how the sounds are perceived, how the sounds are received by the auditory organs. Now it is in major about speech perception. Actually there are two things, sound reception and sound perception. Sound reception, I mean that whatever is related to the reception of sound waves by the human ear. You know, ear is the organ, auditory organ, which receives sounds. And when we receive these sounds, we receive them in the form of air pressures. Again, a sound waves is actually the set of air pressures. So what we receive in the form of sound waves is actually a set of air pressures. Now that air pressures, that vibrations or that fluctuations is converted to neural impulses, and this all happens from our ear to the end point, that is brain. That from ear we receive the sound waves, and when they reach the brain, they are the neural impulses. Now for all these things, the adequate hearing ability, it is what is meant is that we have the ability to perceive the full range of frequencies contained within various speech sounds, that it is related to filtering our irrelevant background. Filtering our irrelevant background means that we hear what we want to hear and we leave and we try to ignore the other sounds. If you are sitting in a room and so many people are talking to around you, then if you want to just listen to a person sitting in front of you or inside of you, then you can focus. Then you can focus your auditory organ to receive that speech sound more clearer than the other sounds within that room. So this way we have the ability to filter the relevant one and to filter out the irrelevant speech backgrounds. And then adjusting to the speaker's idiosyncrasies. What is speaker's idiosyncrasies is that we have a habitual vocal tract settings, and we have certain sets minds or certain sets of auditory and vocal organs to produce and receive sound. So this way, this is all about sound reception. The second important phenomenon is sound perception. Now what is sound perception is actually that we have received the sound waves. These sound waves, they are being transferred into the form of neural impulses. Now in perception, these neural impulses, we hear them actually, and we have certain sorts of sensations with relation to these sounds. We decode the speech signals into meaningful elements. For example, if we receive a combination of three sound, ba, u, k, and then we receive book, then individually these sounds sets are received, but as a neural impulse reaches our brain, these sounds, they are actually converted into meaningful chunks. Before that it is meaningless, but our brain has the ability to convert these meaningless chunks of sound into meaningful chunks of sounds. Then what we do next, we associate identified elements with mental representations. As according to Saussure, we have the mental representations of all the objects. So what we do when we receive certain words, we try to associate those words with the mental representation, and then we make a link. For example, when I hear a word chair, it is my brain that makes a link between the sound that is uttered, that is received, chair, and between the actual object, chair. A picture of the chair is in my mind, and as soon as I hear the word chair, I get a picture in my mind that what chair is. So this way we associate the meaningful chunks of sounds with the mental representations or the images we have already in our mind. Then what we do next? We associate recognized representations and combinations and constellations thereof with semantic concepts. When we relate those sounds with those mental pictures, then by combining them we get the meanings. By combining the sound chair with my mental picture of, I having a picture of, image of picture in my mind, with combining them I will get the meaning what a chair is. So this way the sounds, they are received by the auditory organs, they are transferred to our brain, and then brain, it helps to decode this message and actually creates a meaningful chunk out of that sound waves. So auditory phonetics is quite complicated because it involves neurology. It talks about not only the ear, it talks about the brain as well. Today our main focus would be with the ear as a hearing organ, because language and brain would be inshallah a focus of our another lecture very soon, when we will be confining ourselves with neuro-linguistics. So give you again a brief description. Yes. Speech perception is part of a complex field of reception of spoken language which covers the following two main areas: the ear, the brain. As I told you, the ear, the anatomy of the ear, the physiology of the ear, the internal structure of the ear from outer ear till the middle ear and till the inner ear, we have a set of organization, we have a typical anatomy, we have typical organs that helps us to perceive the sound, to receive the sound actually. And then when after ear, these sound waves, they in the form of neural impulses, when they reach to the brain converts and decodes the sound waves into meaningful messages. So these two are the most important organs involved in the perception of human sound plus the reception of human speech sound. So this is the major focus of auditory phonetics. Now phonetic aspects of perception, what are these? the physical aspects. The physical aspects are the anatomy of the ear, what are the different layers of and the different organs inside the ear that helps us to collect the sound waves, and then the different organs inside the ear, they have the different functions to perform. Every single organ in the ear, it has a different function in relation to sound waves. And finally, when all these sound waves, they are combined and they are reached to the neural impulses, then what happens? That we have to understand that speech. So the cognitive aspects are intelligibility of speech, that whatever we are listening, it should be intelligible. It should be related to some sort of language that we already know. Because we don't know that language that we are hearing, then we cannot make a meaningful thing, or we cannot calculate code a meaningful message out of that. For us, foreign language which we don't know would be just a combination of certain speech sound, a combination of sound that you are receiving, but without having certain meanings. So the cognitive ability is related to the languages or language you know already. Cognitive ability is not only the intelligibility of speech, but at the same time it is the perception, because it is related to the differentiation between vowels and consonant sound and so many other types of sounds, etc. So these all things are important in relation to auditory phonetics. So as I mentioned before, that our today's lecture would be primarily based on the physical aspects and with in relation to the auditory organ, that is ear. Because we receive sounds with the help of ear, so this is a figure of ear. If you look at the picture, the points 1, 2, 3, 4 and 5, these are all those points, and where the important organs of the ear are located, which help us to transfer this combination of air pressures into a form of certain nerve impulses. To make it clear that ear does not help us to decode the message, it only does what it does, that it gets the air waves, converts them into certain sound waves, and then from outer ear it reaches to the inner ear of the layer, and finally to the nerves, from where it is further transferred to the brain. So these points marked over here are the important areas of the ear which help us to receive these sound waves. I will start from the outer ear. Outer ear. In outer ear, there are two important organs, auricle and ear canal. The auricle is externally visible portion of the ear. If you look at the ear, what you can see as your ear, in this inner portion, this outer portion, the visible portion, it is known as the auricle. And what the next important portion is this ear canal. If you observe your ear, then there is a canal that moves from outside of the ear to the inner parts of the ear. It is an air-filled passageway, almost 2 centimeters long, from the outside to the eardrum. What are its functions? Acoustic waves fall on the external ear, because the external ear or the auricle is the first part of the ear which receives the sound waves. So what it does, it funnels down the ear canal and set the eardrum into vibration. The set of high pressure and low pressure air waves, they are travel from outer ear to inner ear, and then they make the eardrum fluctuate. So from outside to inside, it helps the air waves to move. Now what does auricle do? The auricle and ear canal, they form an acoustic resonator that amplifies frequencies near the resonant frequency, that is 3000 Hz, to about 10 times the air pressure at eardrum versus the entrance to the ear canal. So according to these calculations, this outer ear, the auricle parts and the ear canal parts, they actually receive the ear sound waves, and they calculate the frequencies, and then they create certain sort of resonance, and then transfer these resonance, these vibrations to the middle part of the ear where the eardrum is located. So next is middle ear. In middle ear, the important organs are eardrum, middle ear cavity, and eustachian tube. Now eardrum. The eardrum is actually a membrane at inner ear end of the ear canal. As long as after this 2 centimeter, this ear canal finishes, there is eardrum, which is a thin layer of a membrane-like structure, and also known as tympanic membrane. What happens that the sound, it strikes with this ear. First of all, after from outer to central ear, it strikes with this eardrum. Then middle ear cavity. In middle ear cavity after the eardrum, there is an air-filled cavity is there in the bones of the skull. Then in this middle ear cavity has the auditory ossicles. Auditory ossicles, or if you know a little bit about the ear, the bones. As you know that there are 3 small bones inside our ear, a part of the middle ear, known as mallet, anvil and stirrup. These 3 small bones form a mechanical linkage between eardrum and inner ear. Eustachian tube link to the pharynx, opened when necessary to equalize air pressure in middle ear and outside. Now functions of the inner ear. What inner ear does? Now outer ear has received the vibrations. Now these are vibrations, they have been shifted, they have been made the eardrum to vibrate. And then when the eardrum moves, it transfers that air pressure layers, vibrations, into mechanical movements. These vibrations of the eardrum is transmitted and amplified through the mechanical lever system of the auditory ossicles. What are the auditory ossicles? I told you, the 3 small bones. They actually maximize or minimize the frequency. And finally, what does the middle ear do? It protects the ear from excessively loud sounds. If the sounds are very much loud, as you know, because we cannot hear the sounds having a certain loudness more than having, they have a fixed range. If we cannot hear the sounds higher than that range or the lower than that range, and it is the function of the inner ear that it stops the loud sounds with 90 decibel and more to enter into the final or the inner ear portion. Now inner ear. In inner ear, there are the important organs are that actually the inner ear is a small intricate system of fluid filled cavities. There are certain cavities which are filled with fluid. The first one are semicircular ducts. Semicircular ducts are responsible for maintaining equilibrium or balance. It helps us to maintain our body balance. Then there is cochlea. Cochlea is a coil-like structure where transformation of mechanical vibrations to electrical signals to be transmitted and processed by the central nervous system takes place. Cochlea is a very important organ inside the inner ear because it helps to create that it helps to transform the mechanical vibration created by middle ear into some sorts of signals that are transmitted to brain. Then there is another shape, a snail-like shape, which is around 3 by 4 turns and 3.5 centimeter if unrolled. The length is 3.5 centimeter is if unrolled, but in the roll form it is just like a snail-like structure. divided into three regions along its length by the cochlear partition, because the cochlear partition, it divides it into the different areas. Now if you look at this picture, this is the outer ear, this is the ear canal from outer ear up till the inner ear, and I sound waves, they enter from ear into this inner canal, it reaches up till here, and this is the eardrum. The ear sound waves, they make this eardrum vibrate. Then this is the, from here the middle ear starts. In middle ear there is this eardrum, and these a structure, this area where the three small bones are there. If you look at these malleus, incus and stapes, these three small bones, what they do, they transfer these vibrations from here to the next part of the ear, which is inner ear. In inner ear, this is the cochlea, the cochlear like structure. Then this is the, this area is a snake like structure where there are the semicircular canals. This is cochlea, this is the eustachian tube, and this is the important part from where the message, the sound waves, they travel from inner ear to the central nervous system. And again the different types of nerves are there which takes these sound waves, these sound messages, signals towards the brain. There are vestibular nerve, there is a facial nerve, and there is a auditory nerve. These all nerves, they combine, they together, they take the sound signals now transferred into some other form and can take them direct to the brain, or the, so that we call the central nervous system. So what happens, that ear, it collects the sound waves, but then these sound waves, they are converted into neural impulses. Sound pressure variations in the form of vibratory movements of the stirrup reach the oval window. This is the step-by-step procedure by which the sound waves, they are transferred into neural impulses. In the second step, the vibrations are transmitted through the cochlear fluid and the scala media, causing movement along the basilar membrane, which varies in width from one end to the other. Then in next step, higher frequencies produce movement near the oval window at the basal end. Lower frequencies cause movements as the helicotrema at the apical end. The next, displacement of the basilar membrane causes movement in the hair cells of the organ of Corti. Actually, at the end of the inner ear, there are certain hair cells. These hair cells, they are the thin hair-like structures which help to gather these nerve impulses. Each hair cell consists of hair bundles that in turn are composed of about 100 very fine filaments called stereocilia. The movements of the stereocilia initiate electrical currents through conduction channels in the hair cell membranes. And finally, the nerve fiber of the auditory nerve transmit these impulses to the auditory center of the brain. So this way, the sound we hear has different layers of the process, that from outer ear and finally reaches to the brain, speech and hearing. Certain localized area of the cerebral cortex. Now finally, when the sound waves, when the sound signals, now I won't call it a wave, it would be a signal, some sort of nerve signal. These nerve signals and these nerve impulses, they would reach to a certain portion of the brain. And through certain experiments, yet again not confirmed with a question mark, there are certain localized areas of the brain where these auditory signals are received to perform various mental and physical functions, including speech production and reperception. Linguistic abilities have long been known to be the localized primarily in the left hemisphere of the brain. Again, as we are not dealing too much with the brain today, but again it is said that the left hemisphere of the area, if you look at this picture, this area is known as the posterior language area. It is said that all things related to the language, they are stored somewhere here. But again, you know, it is not yet proved. Only there are certain evidences, certain proofs have been gathered that sometimes it happens that the people, when they have this damaged left hemisphere, they have problems with their language production. So this way it has certain proves that this way we can say that the language, it is located in the left hemisphere of the brain, or as I have highlighted, this is the area where it is said that the language, this is the particularly a language area. I hope today's lecture was quite interesting. We studied a lot of things. We studied about acoustic phonetics, what are the sound waves, what are the properties of sound waves, and what a spectrograph is, and what are the uses of the applications of acoustic phonetics. At the same time, we studied auditory phonetics with respect to ear as an auditory organ, and little bit knowledge about the brain as well, and how we actually perceive these sounds. Because as a normal human being, as a common human being, you are not very much familiar with these processes. But as a linguist, as a student of phonetics, I hope this knowledge will help you to know about this reception, production, and articulation of the sound or expound or the speech sounds. Inshallah, when we will meet next week, we will continue with the phonetics, and our focus would be on the vowels and the consonant. So see you next week. Allah Hafiz.